This is a AIPMT question in moving charges and magnetism. The question says an electron is moving in a circular orbit of radius r making n rotations per second. What is the magnetic field produced at the center is? So, first thing is when a current is passing in a circular conductor, magnetic field at the center is mu naught Ni by 2r, where n is the number of the turns, r is the radius of that circle, I is the current passing. But electron is going only in one orbit. So, n equal to 1. So, B at the center is mu naught I by 2r. Everything is fine, but I do not know what is I is. What is the current generated by the electron, that I have to find out. If I know that I can substitute here and get the answer. You know, current is defined as rate of flow of charge. The charge that is moving is here electron. Electron takes certain time to rotate around the circular orbit, that is called time period in any rotatory motion. So, E by T is the current, but we can further write, you know, like time period can be written like omega, angular velocity can be written like, for any circular motion, rate of change of angular displacement. After one revolution, omega can be written like angle covers after one revolution when electron completes one orbit is 2 pi, time taken for the revolution called time period. That implies in the place of time period I can write 2 pi by omega. So, current will be rewritten as I equal to E by 2 pi by omega, that is E omega by 2 pi. But omega can be further written like 2 pi into 1 by time period. 1 by time period can also be written like reciprocal of the time period is frequency, where n is the frequency. Frequency is number of revolutions that it makes per second. It was given like n rotations per second, so it matches to the given data. So, in the place of omega I can write 2 pi n. That implies current becomes E, omega is 2 pi n by 2 pi, E and E will cancel. So, current is E into n. Once I got the value of the current, I can substitute that current in this equation and get the magnetic field. That implies magnetic field at center of orbit when electron is revolving around it is mu naught by 2 pi. In the place of I can write Ne. So, our answer is mu naught Ne by 2 pi, mu naught Ne by 2 pi. Of course, by r is there, mu naught I, in the place of I have written I, by r is there. So, mu naught Ne by 2 pi r is the answer. Option A is the answer for the problem. That is how we solve this problem. Thank you for watching.